Alrighty, so in this video, I'm going to be doing two different examples of how to find the inverse of a function. For the first function, we've got f of x equals 2x plus 6. Now remember, whenever we're finding an inverse function, we first want to determine if the function even has an inverse by thinking about whether it's one-to-one or whether or not it passes the horizontal line test. So if I think about this function, 2x plus 6, I know that it's a linear equation. And if I want to check that, I can graph it, and I see right here that it's a line. So it is in fact one-to-one. It will pass the vertical line test. Every x value has exactly one output y value. Every y value has exactly one x value. It is 1-to-1. So if that's true, then we're ready to find our inverse function. So the first thing that I'm going to do, just to help myself out, is I'm going to rewrite my f of x back in like just normal y form. Y equals 2x plus 6, so that I have a y and an x, because we're going to take these and we're going to exchange our variables. We're going to replace x with y and y with x. So I will have x equals 2y plus 6. Next, we're just going to use legal algebra moves to solve for y. So solving for y, I can subtract 6 for both sides, and I have x minus 6 equals 2y. And then I can divide both sides by 2. Remember, to divide this entire side by 2, that means that I'm going to divide both of the terms right here by 2. So I'll have 1/2 x minus 6 divided by 2 is 3. So I have y equals 1/2 x minus 3. This would be my equation. Because this is an inverse equation, we can replace y with our notation for the inverse. F inverse of x is equal to 1/2 x minus 3. And that's going to be my inverse function. Now, remember, we did mention to think about if there's any restrictions on our domain. Because x and y are switched when we're finding the inverse, if we think about the domain and range of our original function, then the domain is going to become the range, and the range is going to become the domain of our new function. So let's think about that. From the get-go, since this was just a linear function, both our domain and our range were from -infinity to infinity. You can see that again on the graph if you need to. So that means my domain of my inverse function is going to be this range here from my original function. So my domain would be -infinity to through infinity. I can just grab that. Okay, so this would be my final answer. If you want to graph it, you can see what the inverse looks like. We have 1/2 x minus 3 would look something like this. And notice anytime you graph an inverse function, it's just your function reflected across the line y equals x, and I see that it looks like that, and I see that my domain is in fact -infinity to infinity. Okay, let's take a look at this second example. Now we've got f of x equals x plus 3 over x plus 5. So a little bit different. Again, let's start by just making sure that our function is one-to-one and that it even has an inverse function. And if I graph x plus 3 divided by x plus 5, I have something that looks like this. And I see that it is one-to-one. It will pass the horizontal line test. Okay, so let's follow the same process. I've got y equals x plus 3 over x plus 5. I'm going to exchange my x and y, and I'll have x equals y plus 3 all over y plus 5. Okay, now this one's a little different solving for y because I've got a y right here and right here. But let's do our best to see if we can solve for y. I'm going to start by multiplying both sides by this numerator, y plus 5. Move that over, these will cancel. And I'm going to distribute my x, and I'll end up with xy plus 5x equals y plus 3. Okay, my goal whenever I have something like this is to get my y terms together and my terms that do not have y together. So I'm going to subtract this y over to this side, and then I'm going to subtract my 5x over to the other side. So my y's will cancel, my 5x's will cancel. On this side, these are not like terms, so I'll end up with xy minus y. And on the other side, these are also not like terms, so I'll end up with 3 minus 5x like this. Just moving things around a bit. Okay, the reason that this is helpful is if both of these terms have a factor of y in it, then I can factor out that factor of y so that I can have 1y over here that I could solve for. That'll leave behind in this first term a factor of x, and in the second term a negative 1. Let's check. Y times x is xy. Y times negative 1 is minus y. This is the same thing, just in a different form. Equals 3 minus 5x. Okay, now that I have just this y over here and I want to solve for it, since I'm multiplying times x minus 1, to cancel out that entire factor, I can just divide by x minus 1 on both sides, and I end up with y equals 3 minus 5x all over x minus 1. So this is going to be my inverse. F inverse of x equals 3 minus 5x all over x minus 1. Great. Okay, now let's think again about our domain restrictions. So let's go back to the domain and range of this function. So original function has a domain of from negative infinity all the way to this vertical asymptote right here at negative 5. Then we stop. And then the second piece of the function goes from that vertical asymptote at negative 5 all the way to infinity. Thinking about our range, going from the bottom to the top, we're going all the way from negative infinity to stop at this horizontal asymptote right here at 1. Union, the top of the function goes from that horizontal asymptote at 1 all the way to infinity. Okay, so our domain of our inverse function, remember, should be the range of our original function. So our domain is going to be from negative infinity to 1, union from 1 to infinity. And this would be my final answer. If I want to graph that to see what it looks like, I would have 3 minus 5x divided by x minus 1. There it is. And we can see that there is a vertical asymptote at 1, which makes sense right here. And again, if you think about a line y equals x, we can see that the inverse is our original function reflected across that line.